So page 7 of the synchronization notes. What I want to do here is diagram what's happening with that barrier synchronization. And so we're going to have our count variable, and its initial value is 0. And let's have task 1, task 2, up to task n. They will all start in the ready state. And for argument's sake, just to keep this simple, let's assume that task 1 runs first. And so I'm not going to list the mutex instructions. Let's assume that it acquires and releases the mutex correctly. So it's going to increment the count, and that will cause the count to be 1. And then it will check the count to see if it's equal to n, which it won't be because it's the first one. So it's not going to signal the turnstile. Then it will go to step 3 and it will wait. Okay, let's say wait TS. So this is for the turnstile. So it's going to wait the turnstile, at which point it will be blocked, and then task 2 can run. So task 2 will increment the count. But we'll check it will still not be equal to n, so it will wait on the turnstile, and that will cause task 2 to block, because remember the turnstile was initialized to 0. And then, oh sorry, I forgot to increment count here, so it went up to 2. And eventually task n will run, and it will increment the count. So count becomes n here, and then it is going to check that the count is equal to n. So let's just add a note here. So this is equal to n. So what it's going to do is it's going to signal the turnstile, and that is going to cause one of the waiting tasks, or one of the block tasks, to become ready. So let's just say that task 1 was first in line, and so it becomes ready. And so let's just say that task n, after it signaled turnstile because count was equal to n, then it will go to step 3 and it will wait turnstile, and the turnstile is not available, or is 0, so it is going to become blocked, at which point task 1 can continue. So task 1 is the only task that is not blocked now. So after it returns from the wait turnstile, the last thing it does is signal turnstile, and that will unblock one of the other tasks that are blocked on the turnstile. So let's just assume that task 2 becomes ready at this point. So task 1 has finished with the synchronization. It will now proceed with the body of its while loop. So task 2 is now going to take its turn, I guess, exiting from the barrier synchronization. So it waited, and when it wakes up, it will signal turnstile, and that will cause another waiting task to be unblocked. So let's just say that is task n. So then the last thing that task n will do, it will signal the turnstile. And in this case, the value of the turnstile becomes 1. So at this point, turnstile becomes 1. And so just to help you see that, we had a wait here, a signal, a wait, a signal, and a signal. So if you count those up, we've got 3 weights and 4 signals. So because the turnstile is left at 1 instead of 0, the implication is that the barrier is not reusable.